My name is Chad Williams, and today we're going to talk about a one-sample t-test. So let's start off by making some data. We're going to just use the rnorm function like we most often do. And let's get 50 people with a mean of 5 and a standard deviation of 2. And what we should always try and do is plot our data first. So let's do that with a histogram here. And what we see is a normal distribution with about 50 individuals there. Now the question is, one sample t-test means we need to compare it to something. So a one sample t-test is usually comparing it to a mean of a population. So what is our mean of our population? Of course here it's all simulated data, so let's just choose one. Let's see if this data is significantly different from 0. We can already see from this histogram that the data is pretty likely different from 0 because there's only one point even close to 0. Let's show that statistically. What we're going to do is we're going to use the t-test function. So I'm going to actually put it into a variable called t-test result, and our function is t.test, and what it needs is our data. So first let's put our data in there, and then what we need to do is tell it what we're comparing it to, and that's going to be a mu of 0. So our mu of 0 is our population mean. Now let's run this and see the results. So our results come out down here. First couple things we'll notice is our degrees of freedom is 49, which makes sense because we have 50 people, and degrees of freedom with the one sample is n minus 1, so 49. We see our t-value here, which is 20.306, and we see our p-value here is very small. So yes, they are statistically significantly different from 0. Another thing we get is our mean, which is 5.25, which is close to what we designated it as. And we have a 95% confidence interval around that mean as well, which would also tell us if we were significantly different from 0. That's fairly simply it. And so what we can do is we can write this out. Let's do it with a comment as our t-value of 49 degrees of freedom equals 20.31 with a p-value of less than 0.0001. And there we go.